And we are live. Welcome, everybody. This is the Coding with WebLN workshop with my good friend Boomy over here. Boomy is the founder of Albi. Boomy, you want to talk a little bit about Albi, what you do, your kind of experience with WebLN so far?
Yay. Awesome. Good to be here. Super excited about this whole event, this whole session, and all the stuff that's happening here. Yeah. Albi is a browser extension. We're gonna see that today. We do a bit of coding, WebLN coding. The general idea is to bring Lightning to the web. To allow web developers use the Lightning network as native as possible. So basically, by calling some JavaScript functions, and with that adding, for example, monetization options into any web app. So, and Albi is one of the browser extensions, or hopefully, the best one that you can use to add Lightning.
Yeah,
To the web
totally.
app.
Yeah, I think the best way to do this, right? So I think you've got a couple slides that we can just do like a quick overview of like the internet stack and where WebLN injects into that. And then after that, you've got a couple, like we were just on Replit and you just selected two random apps, and then we're going to hack around on getting WebLN into them so that we can monetize the app.
Exactly, that's the idea. So I looked up two applications, random applications, two nice featured applications on Replit. I mean, there's so much fun stuff what people are building there, but it's two small applications, plain JavaScript, plain HTML, so it's for easy for everybody to run. I mean, there is a bunch of code there, but we ignore that. That's doing some fun stuff there, and we just in a few parts we add some WebLN stuff to request payments from the user. And yeah, that's it for today already. We'll see. Yep. And I mean, it's important to say if somebody has questions, or if like you also jump in, let's take that and let's also have a discussion there.
Definitely. So I'll be monitoring the chat. And so if you want to share your screen, we can jump in, and then I'll kind of inject as people have questions, or as you probably get into things that I'm a little unfamiliar with, because you're a world-class front-end dev. And for me, I'm just a lowly back-end dev.
I consider myself definitely a back-end developer. So. Right. But the fun thing is here, it's so simple. There is like, in the end, it's the goal is like that it's a native JavaScript function that the browser provides, and that's what you call. So you don't need to be a front-end developer to do these kind of things. It works from the front end, but let's get to that. I have 2-3 slides that we in 2 minutes jump over.
Yep. Can we share screen again? It's not sharing.
And yes, I'm sharing my screen.
Cool.
I have my travel set up here, so I only have one screen, but I hope you see my slides now.
Yep.
Does this work? Yeah.
Yep. You can just hit hide on the bottom where it's StreamYard.
Yeah. And I might need to get power in a minute, but we will do that. Here we go. So WebLN, basically Web plus Lightning. The idea is to have a unified standard for websites to interact with the Bitcoin Lightning Network. I guess we already talked about that. But I want to start a little bit before what we do today, and with the World Wide Web, basically, right? So the World Wide Web is an information sharing network, probably one of the most the biggest innovations in at least in my lifetime, that had a huge effect on my life and all our lives, basically. We cannot live without it anymore. And the biggest change that it actually brought was that we had that we moved from a broadcast model where we have only a few senders and many receivers, and all the information is coming from one party. So we only could consume information. We moved to the internet model, where we suddenly have many senders, many receivers, and we had a direct sharing of information. So basically, everybody can publish something on the web. Everybody can publish some web app. It's gotten super simple to do that, no matter who you are and where you are. And so the internet model brought a great reduction of cost for publishing. You suddenly have a global audience, and we have open protocols that enable this innovation. And we have the most innovative platform with the tools like JavaScript, HTML, CSS. So you only need a browser and you can visit any web app, and those are super accessible for any developer there. But with all these standards that we had for information, we had no standard for economic interactions. So we could transfer information in a standardized way, but we couldn't transfer for value. I mean, we all know that, right? We all live in the Bitcoin world now, but I think that's you cannot emphasize enough on that. To pay online, we still had to transfer information, and we still have to do that, right? You have to enter your credit card information into a website to transfer information to some acquirers, to card processing companies, etc. And you always needed those intermediaries to facilitate these transactions, right? And with that, monetization relied mostly on advertisement, because it was not possible to have an economic relationship as we had a relationship in terms of information sharing. And so all the monetization models basically built on information, which means a user wanted to get some information from a website. The website provided that information and always injected a little bit like ads in it, a little bit more information, a little bit more data in it, in form of banners, tracking pixels, and so on. And for that, they also got money from advertisers. So the online monetizations models were still stuck in the broadcasting world. This worked pretty well in the broadcasting world, right? We had television and radio for that, but it's not working in the web model. So, but as we already all know, and thanks to the Bitcoin world, the future is now. We got the Bitcoin network. And the fun thing is, I mean, you already talked about that, and it's the whole thing that brings us here is we actually in the HTTP protocol, we have the status code 402 that we now finally can fill this functionality. So even back then, they were envisioning already this future where we have like native internet money, which we now have with the Bitcoin Lightning Network. So in the value for the internet age with this protocol now sets flow like information, right? We have a peer-to-peer model, and now suddenly direct economic relationships are possible, which is a huge innovation for all the developers out there that now can add monetization options quite easily. So what do we do with it, and how does it work? So let's get started with WebLN. This is the topic for today, and let's look at the basic concept. That's what you all know. I mean, I'm not good at drawing diagrams here, but I guess you you understand the concept. We have a web browser. The web browser typically talks to a backend. The backend, has all the functionalities and information back. The browser sees it. That's basically it. The new concept here a little bit is, or the new concept that we have to first wrap our head around a little bit is that additionally to the web browser now that sees that displays all the information for the user now has a Lightning wallet, basically, a WebLN provider that is embedded into the browser. And through this WebLN provider, the web browser now, this application that is shown in the browser, can talk and can interact with the Bitcoin Lightning Network. So that's kind of the idea, that WebLN provides a standardized interface to the user's wallet and through that wallet, these applications can interact with the Bitcoin Lightning Network. So you don't need to have like complete access to the wallet. You basically, as an app developer, just have a interface, a standardized interface to talk to the wallet. So you don't need to embed a wallet. You have an interface to talk to the wallet. Cody, do you have a comment on this or a question already on this one?
Yeah, so just like very important point that you're bringing up here, right? Of that in terms of secret management is that there, as the developer, there's our secret management, which is like on the back, like the reason why we want to have all of our keys be back-end server side instead of injected into the client is because like we don't want the client to have our secrets. But the client also has secrets now, and those secrets are going to be their Bitcoin wallet key, Lightning wallet keys, and just like some way of doing economic transactions. And WebLN is the standard for going across. And so it's not just with users now, even, right? Like now we have to think about, like, with the advent of AI, we're going to have agents that are interacting with our applications, and they're going to have access to Lightning wallets so that they can make payments and all those kinds of things. And so what's nice about this is that we don't have to know anything about the user. The user doesn't even have to be like a real user necessarily. They could be an agent, and the standardized interface for going between them is going to be passing these invoices back and forth. And so you can pass the invoice back, they pay the invoice, provide the proof of payment to you, and then they can continue with what they were doing. Right. And that way I don't have to, because I think you were the one who first to like explain this to me of how this works, is that when you swipe a credit card, it's basically like giving the person that you swipe the credit card for access to like do whatever they want with your credit card. And you're kind of trusting them not to, right? And so you never want that to happen with your Bitcoin keys, because Bitcoins are bearer instruments. And so if you get access to the client's keys, then you own the client's money. And so for this one, it's you never touch or see their keys, because you're always interacting through this WebLN interface where I just present an invoice, you separately pay it, and I can't see the keys that you use to pay it. Right?
Exactly. Yeah. And if you compare it to the card payments, because it's so sensitive data, actually, even because we're kind of used to it, we don't treat it as super sensitive. Like the card industry tries to make up for that with PCI DSS certifications and so on, that you as a normal web app, you are not even allowed to handle that information. You always need an intermediary. You always need to go through a payment service provider that has the security certification to be allowed to handle card information and to do this processing in the name of you.
Yeah.
So, which is a very different concept also, but it's only needed because you can only share, again, it's only needed because you can only share this information, like the card number, with somebody that does something. And now the concept is very different, because now the application can only, because it's digital, the application can simply request a payment from the user's wallet, and the user's wallet does the payment through the network, through the Lightning Network, and gives back, for example, some receipt that confirms the payment. So you really have this direct interaction that wasn't possible before.
Totally. All right. You think we're ready to go start coding? Jump over.
Let's check it out. Maybe we quickly, before we start, jump into the code. Actually, I can quickly show you, for the people who haven't seen it yet. You can look at the browser extension, because that is what teaches the browser WebLN, basically. And on the desktop here in Firefox or Chrome, typically we do that with an extension. So this is what Albi is doing. It's a simple extension that you can simply add to your browser through the Firefox or Chrome add-on stores. You simply add it, add an account, connect it to your wallet, or create a new account there, and that's basically it. And with that, you have, let's stay here. you have this icon over here. That is your wallet for your browser. So I have here a bunch of accounts in there. In Albi, you can actually connect any node and account that you want. So you either can use an Albi account here right now. We have this to make it easy for people to get started also. But you can also connect to an LND node through the REST interface, or through LNC. You can connect it to LN bits, for example, and all the other options. Core Lightning, obviously. So whatever you have there, and with that, the browser can talk to your node, to your account.
And something I found really helpful for understanding this is that could you just open up the developer tools real fast and just kind of like look for window.webln, which is like something that's going to be present now in the browser.
Yeah.
So that's what the browser extension is doing, is that it's injecting this WebLN object into the browser. And so now the client actions can detect whether or not the browser that the client is using supports doing Lightning payments in this way. And so whenever you're adding to your code that you want to do like Lightning payments for these things, the normal first check that you do is if window.webln and window.webln is enabled, then that means that the WebLN is present, so you can interact with this interface, and the client has a wallet that supports doing sends and receives via this protocol.
Right? Yeah, exactly. And you can compare that to any other native browser functionality, like for example, access to the camera or access to the microphone. This is a standardized native JavaScript function that the browser provides to the web application to interact with those tools, those functions, like getting an image from a camera.
Exactly.
And the WebLN part is this native function added by an extension or a browser to interact with the Lightning wallet.
Exactly.
So do you actually in Fedi you also have an embedded browser, right?
Yeah. So we have this is exactly what you can do with this, right? So for WebLN is that if you want to give somebody access to it, you need to control the browser that they're using, right? And so within Fedi, which is a mobile application, like normally you have to like switch over to a browser. Well, once you go out of Fedi into a separate browser, then you can no longer inject that window.webln, right? And so what we do is we have an embedded browser inside of Fedi. It's just like the React Native embedded browser that you use. And then what we can do is we can intercept WebLN calls and route those to the Fedi backend, like the Fedi backend. And so the experience you'll get is that when this is trying to do a WebLN interaction, it'll open it up in Fedi, right?
So. Yeah. And the cool thing is, you as a web developer, you don't care where this application is running. It doesn't matter if it's running in a user's Firefox on a desktop, where a user is using Albi, or if it's running within your integrated browser in Fedi, or Breeze, the marketplace, also is using WebLN. Blixt supports it also internally there. So there are a bunch of these, and as a web app, you don't care where it's running. So it's completely up to the user. That's where that's the power of the standardized interface here.
Exactly. All right. So on to code.
So yeah. Let's look at these 2 or 3 lines of code. So for those who also want to follow along, I mean, a good entry point is the WebLN website. There is one webbtc.dev/WebLN, but especially a good starting point is the webln.guide. That describes the concept, what WebLN is, and gives you the reference of this window.webln object, where we have a bunch of functions here. So the main one that we gonna look into today, I guess, is the send payment one, because it's a bit about paying invoices, and we want to monetize a web application and request a payment from the user. So that's the one that we're gonna look into. We'll see if we want to have some time and fun later. Maybe we can look at another one. Yeah, so the main one that we look into is the send payment one. But just to mention the other one, obviously you can not only send a payment, but you can also request an invoice from the user that the web application pays, for example, to do a payout. You have different kinds of payments. The send payment is taking a WebLN invoice. You can also do a key send payment, which is often used in the podcasting space. And you can do things like.
For anybody who's not tracking for these, is that for a WebLN invoice that's I'm hitting the service and then it's giving me back a invoice and then I pay the invoice. The way that I prove that I paid it is that I provide the pre-image for the invoice. And so the invoice contains a hash. If I pay it, then I get the pre-image, and then the pre-image when hashed equals that payment hash, right? For doing a key send payment, that's a way where I don't have to do that round trip, because what I'm doing is I'm sending directly to a Lightning node, right? And so there's some Lightning node. I know where exactly I'm sending this thing exactly. And so I don't have to do this round trip. I just send, hey, I'm just pushing you this money.
Yeah.
Right? Is the difference between those two.
Yeah.
Here it says, how do you limit the exposure of your node wallet to the browser extension? I assume you're capping the amount it can send payment wise, right? Boomy, you're an excellent person to answer this question, because that's exactly what Alby exists to do.
Yeah, I mean, so there are multiple levels where you can do that. First of all, if you, for example, connect your Core Lightning node or LND node, you can already set permissions on that level, that you can define a macaroon, or with LNC a session, or with Core Lightning it's a rune, right, where you can set certain permissions that in this case Alby can only do certain calls on your node, and do only access a certain amount. But Alby itself is your wallet. So in Alby itself, first of all, you will always get prompted. So Alby will ask you, we will see that in a second, when a website requests a payment, the user will get a prompt to confirm it, and only then the payment is done. Then the payment, the call is made to the account or to the node, and then the payment is done. But you can also set a budget within the application itself, because you might not want to get prompted all the time. And then you can set a budget for each website to make sure that the website never has access to the node that you don't want.
Yeah, and this is something for we're going to go a lot deeper into with Hannah from Lightning Labs. She's going to do a workshop on aperture and macaroons. And so macaroons specifically are one of the ways that you can cap the amounts, because you can, for example, take your root macaroon and add additional caveats to it. It says, hey, you can only do payments up to this amount, or you can only have a total of 15 payments over this 10-day period or whatever, right? You can do that using macaroons. Macaroons are just fancy cookies, right? And so it's just a really good way of adding these additional caveats. If you didn't want to give Alby, for example, access to everything that your node can do, or you only wanted to give it access to certain functions in your Core Lightning node, you can use the runes on Core Lightning, which is kind of like macaroons, to limit its functionality in that way. Right. Yeah. So it's very, very powerful, especially as we're talking kind of on the AI side with agents, because you can give agents access to caveated macaroons. And so the agents can only do one of 5 things using your Bitcoin Lightning wallet, if you caveat the macaroon in that way.
Yeah. Right? Yeah. And at the same time, you additionally have this layer within the application itself. So within the wallet itself, that has the permissions that it only passes on to the website.
Yeah.
So, and that's also important to to remember, these calls are basically just like function calls into the extension that prompt the user. This is instead of clicking on a link or scanning a QR code, we now have a JavaScript interface to do that. So you can really compare it to scanning a QR code, which is holding the invoice, and your wallet pops up and asks you if you want to pay this invoice. So instead of scanning the QR code, you have a JavaScript function. But after that, it's going to be the same thing. Your wallet decides on what to do with it and asks you for a confirmation, or then pays it on your behalf.
Yeah.
So
cool.
Yeah. And the great thing here is also, we will see the importance also of that also over the next days, is this communication is two-way. That's a big difference to what you have with a QR code or a normal link that you have. With a QR code, the communication is always only one way, meaning I can scan a QR code, so I get the information, I get the invoice into my wallet where I can pay it. Payment is sent through the Lightning Network, but there is no way of giving the pre-image or certain information back to the website that then can interact with that information again. And the WebLN interface does that. So you have the programmatic interface to request the payment, pass the payment request to the wallet, but then you always get a response back, which is with the pre-image that the website then can use again to validate if the payment has happened.
Yeah.
So as you said, for example, to compare also in JavaScript, in plain JavaScript, to compare the pre-image to the payment request, to the payment hash that is in the Bold 11 invoice.
Yep. And that's something, I don't know if we're going to eventually get to this, but for the Lightning address spec, that's something that you'll notice with that, where Lightning addresses, like that one that Boomy just showed, where he's like boomy@getalby.com, is that's a 3-round protocol. So the first round is this a valid Lightning address? And how do I get the callback for where I get the actual invoice? Then you hit that callback, that gives you the invoice, but it also gives you a verify URL, where you have to poll against that in order to see whether or not the invoice has been paid. And so that's like a much worse coding experience. And like, it's kind of like worse for the client versus just having the client be able to directly interact with the wallet and then say, okay, yes, it's been paid and I can continue with what I was doing, instead of having to go poll against this verify URL.
Yeah. Right. Yeah, exactly. Exactly. That's always the question. And also, but we will have a special session on that also, right? On the LN Lightning, LNUL tools and Lightning addresses and so on.
And I did something last night that's about to be posted for wrapping a GPT-4 call with a Lightning address call, right? And so you can watch that one too, where I go through the whole Lightning address.
Bam. Okay.
Cool. Let's go. Let's code. Let's code, Boomy.
Let's write some code. So what I did, so I have looked at some of the fun Replit featured apps here, and we're gonna use 2 of them and add Lightning functionality to it that the user has to pay a few Satoshis to use it. There's a lot of cool stuff here, I have to say. That's always exciting to browse through what people are building here. Quite some inspiration here. So what I thought is we're gonna use this one, which I kind of like, a simple drawing application. Oops, where did I get back? That's not what I wanted to do. Art, draw lines that move is the tagline here, which is kind of fun. It's just a super simple application, just for everybody to follow and to see how it can be done and what you can do with WebLN. So this is a JavaScript application. I can draw, and the line is moving, and I can draw some more, and it gets a bit artistic here if I want. And it keeps moving. And the idea is that now for every line that I'm drawing, I'm requesting the user to pay a few sats. So whenever I have something drawn, the user gets prompted to pay a few sats to me as the developer. And I mean, maybe you can share also the link to that one if people want to.
Yeah, I'll put all those in the notes for it.
If you can do that, that would be awesome. Exactly, cool. But you will find these apps also in Replit in the community section here under the featured applications. So I already forked it. Whoops. So I already forked this application. So I have it here under my account. So I'm always a bit scared of live coding, so that's why I tested it before if it works. But we will delete it now and see if if we can still get it to work. So I have forked this application. As I said, it's a plain, simple HTML and JavaScript application. Has an index HTML, and there's a bunch of JavaScript stuff here. Most of that we don't even look at and care about. What are these utils are to draw these lines. What we look at is, and it is basically just down here. Mouse up. Here we have a mouse down and mouse up functions where we start drawing and we end drawing. So these are the two functions that we're going to look at, where we add now functionality that either when I start drawing or when I end drawing, that we request a payment from the user. I think we're going to add it to the drawing end, because then we don't interrupt the recording of the drawing. And so what we're gonna do here is, the idea is just that, okay, we request a payment from the user, and if it's not paid, we give a little bit of a message. And in this case, I also reload the page. You can do whatever you want there, but this is just the most simple thing to prompt the user, hey, if you don't pay, it's not going to work. So yeah, and now we're going to implement this request payment function. So let's start up here. We do it down here, draw end, that we are in here. Make an async function, request payment. So, and we can actually quickly check over on the WebLN guide. The two things that we're gonna need is, and that any WebLN application is calling is, first we enable WebLN. So that's gonna prompt the user to even allow the website to call any other functions. And the second one, as we already talked about before, is the send payment functionality. So what we do here first is we check if WebLN is enabled. And that's a very simple check. Window.webln. If that is defined, then all is fine. If it's not defined, again, we just, for this case, we alert the user to say use a modern WebLN enabled browser, and we return false. Payment was not done, so that's it. We can do that because WebLN is gonna be is this native object that any WebLN browser is injecting that we can use. So the next thing is we do a WebLN.enable, and we await that, and maybe Let's see what happens if we already do that. And I just have to make sure that I actually.
And so here's just a little thing that I've always run into when I do WebLN on Replit, right? Is that one of the things to notice is that that's attaching to the window object, right? And so when we do run and we look in the web view is an iframe.
Yeah.
And so one of the issues that I run into when I'm doing this on Replit for this is that because the iframe can't access the window object sometimes, right? And so depending on like what you're doing. And so if that doesn't work, then what you can do is you can just hit that open in a new tab on the right-hand side, and that will open this in a new tab. And instead of being in an iframe, it's going to be on like your normal browser. And so then you'll be able to see WebLN. And so if you run into that same issue of that you're like following along and you try to do WebLN and like you can't detect it from inside the web view, make sure you're opening it in a new browser so it can access the window object.
Yeah, so let's do that. That's definitely better. I think also Replit is doing a few magic with this iframe. And the nice thing here is also you can always try it down here in the console, window.webln, right? But let's see what happens if I'm drawing. Did I reload it? Already have an error in here.
Run, I think. Run at the top.
To do run at the top.
The green button.
And we have it in here, request payment. Okay. I have an error here. Reload is not a function.
Oh, because you have to hit run again at the top. So I think it's that big run button at the top to like run and run dev again.
Debugging here also, window.webln. And we have an async function, and I just have to make sure that this function is defined here. It's called here just alert hello from request payment. So because I think because it's a static HTML page.
Oh, okay, yeah.
There is not really much running. We only have to make sure that we are reloading and nothing is cached. So again here, let's check that we have window.webln. That's in here. And we have the call hello from payment request. And I should do that here because I've used it before. Here we go. So we have this call, and here Albi now pops up and asks if we want to give that website access to call functions like that.
That's the WebLN.enable.
That's the WebLN.enable call.
Calling to Albi or whatever Lightning browser extension you're using and saying like, hey, I want to interact with you. I want to send a payment or receive a payment or whatever, right? And so there's that first handshake of should I connect at all?
Yeah. Which we're going to do. And that's all the function that we have so far. So the next thing is now that we have it enabled, now we can request a payment. So for that, response, we will get a response, the pre-image back, and we now do WebLN. And it's always best to do window.webln, even though that's a global object. Window.webln send payment, and now we need to somehow get an invoice in here. For today, invoice. I have prepared a little function, request invoice, that is just generating an invoice from a Lightning address. I'm paying here hello@getalbi.com. We can look at what that's doing later. Let's jump back down here. So we can just call this function that I have prepared. Request invoice. Can actually also, let's do an alert on it that we see what's up with that one. And we pass this one into the send payment call. And let's do a console log on the response. And we still return false just for the sake of it. So we hit save and let's try it again. So we start drawing. Our function is called. This is the invoice now that we got, that we request the user to pay. And now Albi pops up again and asks the user to pay this 21 sats that I have defined. Once we pay it, we get a response down here that we logged, which is the pre-image and actually also the payment hash, which we could use to validate the payment because the pre-image must match to the payment hash that is from the invoice.
Yep.
Okay, so basically now we already have sent a payment. So because of the notifications, because of the screen sharing, I don't get the notification here, but here you see successful paid 21 sats to this application. And yeah, that's that's pretty much it. So basically, it's always like these two lines of code that you need to request payment from users. But we're not done yet. So we still have to, like for this case, we just return if there is a pre-image. Response dot pre-image. Right, and we remove the alert down here. We can leave in a console log to check this out. The invoice, my typing is bad here. And we add the alert here. Yeah, let's just keep the alert here if the user is not paying. So and let's start from scratch. So I remove that Albi doesn't have any permissions for this website. So the first call that we do is the enable call, get prompted again. Albi, we remember that. We have to request the payment here again, 21 sats, and that's it. We paid. We do it again, and again we get prompted. And the nice thing is now, because it's JavaScript and because it's interactive, the wallet now here, Albi, you can set a budget. Whenever I want to use this application, I don't want to get prompted anymore. Let's say until there are 100 sats, just send the payment automatically. I'm going to pay it. And now I can draw a few of these lines. Payment is done. Actually, here you see the invoice, another one, the invoice, another one. And here, because my budget is now used, Albi prompts me again if I really want to pay that amount, which I'm gonna do. Cool. So, and just with that, we now already added Lightning payments to this web app. Do you have a comment or a question?
Yeah, I mean, I just this was a big unlock for me of realizing how simple this was, right? Because for all this stuff, what's cool about Lightning is that because it's an instant, finally settled payment with a bearer instrument, where it doesn't get in the way of the user experience, right? And so for as you're doing it right there, you're doing the payments live, right? Like, so you could see it in the console is that like every time Boomi was drawing a line, that what's called a Lightning payment was going through, right? And there's like basically no latency associated with doing that because the payments are instant. And so if you want to, you can set a budget like you're doing there with Albi. Or what you can do is you can just do an initial payment for a token. And then as long as they have the token, then you don't have to do the follow-on Lightning payments, right? So I can pay for like a token that way. But those are two different ways that you can do it. You can have every single time the user does the interaction, they do a payment. And so that's something where you just know absolutely that I'm always going to be in the black. I'm always making money because I'm passing the cost along to the user as they use it. Or if it's an AI agent, right? The agent is probably going to have to do a purchase every single time it tries to do something, right? It's not going to persist long enough for a token to be useful. It's not going to persist more than like a couple seconds even, right? And so this is a super cool protocol for being able to do this. And using WebLN, it's a really good user experience for this stuff. I think, do you think we have time to do like the second application as well? Just kind of like
we run through it quickly, pretty quickly. It's quite similar, but so we run through that pretty quickly. Exactly. Yeah. And the important thing to understand here is also I don't have to request. I don't need to have an account. I don't need to add my credit card information and all these kind of things. As a developer, I don't need to have a contract with a payment service provider and things like that. It's really just requesting a payment from the user, and as you say, it's like the payment is done, it's settled. There is no chargeback, no nothing, and it can be all these small amounts. I mean, what did we have 21 sats, which is like probably a bit less than a cent or $1 cent here. Yeah. So yeah. So let's check out the second application, which again here is from the community, a simple image editor. So what I can do here is I upload an image. I can edit it a little bit, and I can then save the image and download the image. And what we're going to do is when I save the image, I request a payment from the user to download it.
Yeah. And when we do that, can we just really quickly, because I did yesterday, but just like the flow of doing the Lightning address, if we could just kind of like look at those.
Exactly.
Maybe the calls directly in the what's called in the console or something.
Yeah.
But I think that flow of like you have like Cody@replit.com, which returns back, use the callback, and then use the verify, right? Like I think that's just a super user-friendly way of, well, a developer-friendly way for doing the interactions, and we kind of skipped over it for the how we got the invoice on the first app.
Exactly. Yep, that's what we look at now. So because I have the code here already, and we're gonna look at this part now. So again here, you can fork it. You will also find it on a MyReplit, my fork. Again, I specifically chosen two apps that do not have any big build pipeline and so on. So we can really start simple JavaScript here, simple HTML. It's loading one script file, which is this one. And it has a function, save image. And in that function, we do quite a similar thing again here. Is we request a payment. If it's not paid, we just do nothing. And that's it. So if you have real applications, I mean, you probably would want to protect a few things a little bit more, but for getting started, I think this is completely fine. So we request the payment. We do exactly the same as we had before. We check if WebLN is enabled. If not, we return. We get a payment request, a Bold 11 invoice. We enable WebLN. We send the payment. Again, get the response, and here we could do again the check of the pre-image if it's paid, and that's about it. So let's quickly look how it works. Loading it, uploading my image. Let's make it a little bit gray, and I get prompted, and obviously because we have this memory here, I want to see both of the prompts for the first time. So let's make a change, save image, and again I get prompted. If I want to allow WebLN, I do that, and I get requested for 21 sets. Setting again a budget. Let's set a budget to 3 sets. I pay, and the image gets downloaded. Whoops, works even. Cool. And yeah, as you said, now the question is, where do we get the invoice from? So one of the most simple things that I find is to actually use Lightning addresses or LN to request an invoice. I could connect also this application to a node, give it again a macaroon to request an invoice, or some other API. Zebedee provides an API. Albi also provides an API. But what I like about the LN spec is that it's, again, a standard, and you can use with that any Lightning address simply to request an invoice. Why can you do that? Because we have the 2 calls that you have to do. Here, basically, hello@getalbi.com translates to this one. And what did you have?
Just really fast to focus on this, right, is that you start with I'm like Cody@replit.com or something, right? And then the way that I parse that to check if it's a Lightning address is that I go to replit.com/.wellknown/LNURLP, which is the Lightning URL payment protocol /username. And so this was something like I demoed this a little while ago when like Boomi helped me make this, was making a Lightning address server that you could use off of your Replit username. And the reason why is because what we were doing on the back end with that was we were just eventually, when you do the Lightning payment to that user, we would route it to you as Replit cycles, right? And so this is a really cool abstraction for being able to do these payment protocols interacting with the Lightning network in Bitcoin, where I could use like your Replit username for it, because the usernames are just kind of ephemerally assigned based off of this .wellknown, right? And when you get that back, you get the callback there, and the callback could be anything. So GetAlbi has like a very straightforward one of that. It's GetAlbi LNURL pay /username/callback. But like you could route that off to a different site. You could have the address server being somewhere else. Like you could send it wherever you want, right? And so it's a really, really powerful abstraction for putting layers between these different things, right? So having like a user-friendly front end that doesn't have to deal with all the complexities of a Lightning node.
Yeah, exactly. And also with that, you don't have to give any sensitive data to the application.
Exactly.
The downside is a bit, you have to do this HTTP call, but typically that's super fast. But you don't have to give any sensitive data to the application, and it works with any Lightning address, any LNURL out there.
Yep. So then you copy the callback, and that's where you go get the invoice from. Right?
Exactly.
And this was something I was going to ask you, because Albi requires an amount, but can't you do an amountless invoice now? Aren't you using LND on the back end?
Typically, I'm not a big fan of amountless invoices, because some wallets do not support it, that cannot pay it. They try to send zero sats payment then, and so on. But the idea actually of LNURL is that you provide an amount that you get an invoice is specifically for that amount.
Yeah.
That you then can pay. And in our case also, I want to define the price that you have to pay for my application.
Yeah, makes sense.
One thing is only that those are millisats. You just provide it as a query parameter here in millisats. And whoops, if I would copy it correctly here, then that would work. So amount is 21,000, and I get a JSON response here with a payment request that I then pass on to the wallet.
And you also have that verify URL. And so if you're trying to just do this stuff client side without a server where you could like verify whether the invoice has been paid, then you can have the client pull against that verify URL and then update dynamically for after. So if you present it as like a QR code, for example, that's useful. But if you're doing WebLN, then you don't need to use this verify URL, because WebLN will just pass the pre-image back into the web page.
Yeah. Yeah, the verify is when you have to add this. This is a spec proposal. I mean, LNURL in general and Lightning addresses are very broadly supported. The verify URL is not that broadly supported yet. Sadly, it's a spec proposal, which for our use cases here and use cases like that one is super useful, because and it just completes the case. You can get an invoice from a recipient, and then you can also ask the recipient if this invoice was paid.
Yeah.
So this is what the LNUL what this LNUL spec is for, and it's using just the same kind of format as LNUL is using anyway. So yeah, so let's quickly do that to make it simple, because we have fixed callback URLs. We skip the first one, and I will say something about what I actually do here in a second. But basically, we can just do a const response equals await fetch of this one. I have an amount here actually in a variable defined. So let's use that one, amount mset, and voice equals, we only need to parse it as JSON, await response .json. Put that one in here. Let's comment these two out. And yeah, actually we can just pass this back here already. The response is the invoice payment request. So, and actually, let's try that one even in the console. Because it's so simple, no dependencies, no nothing. We can do the fetch. But we write the amount fixed here. So we did the call, we got a response in here, response object. The invoice is this as JSON. And we need to do await. So here you just see it as a JSON invoice. Invoice.pr is our payment request. What we're gonna use here.
Cool.
Let's quickly test it, so that if somebody uses it, it also works. We do the call, and payment is already done because I have set a budget. Can download it a few times. Now budget is used. I'm gonna get prompted again.
Well, here's a quick question. I think this is kind of like something to start wrapping this up, because we did both of these applications. It's so simple to add WebLN payments into these. Is that WebLN's not using a 402 error code, is it? Is that you're just hitting the button and then it's just passing it immediately to the
yeah. So that's what you would actually potentially do if you have a server involved here.
Yeah.
So which is the fun part then is, right? When I had the save image, right now this is all complete client side and so on, which is great. But if you have like an AI model or something like that, typically you do that on the server. You do an API call to the server, and there the server can respond with the 402 payment required code and also provide an invoice.
Yeah.
And that invoice then I can pass on through WebLN to the user's wallet to request the payment.
Yeah.
So really, WebLN is just this JavaScript interface between the browser and the user's wallet. So it's not doing any HTTP calls. So it's not intercepting any HTTP calls. So it's not using the 402 payment required code, for example.
Yeah. Cool.
So,
all right. So, yeah, I think we'll call it there. And Boomi, you said that you were going to be available for anybody who needs like mentorship or helping out with like using any of the Alby tools, doing some of the more lightning focused things. I know that you and I have been talking a little bit about the AI stuff. Like, are there any like sort of AI wrapped lightning applications or lightning wrapped AI applications that you're excited for that you think Alby tools would be a good use for?
No, I mean, I don't want to say anything here in in the hackathon. I just think this is such a perfect match because, as you said in the beginning, like it's not only about monetization here, as what we did here with a simple front-end application. With the AI part, typically there are much more costs involved and resources involved, and we can have more, agents talking to other agents. For that, we need digital native money, right? And so I'm excited about that. This is now actually possible, and this is a great use case for that. So
and
I
this is
I just want to see what people are going to build there.
and
I think sorry to say that the important thing here is we need to these are new concepts and we need to wrap our head around a little bit. There are like a lot of I see a lot of Lightning developers. Then they know about WebLN maybe or L402, and we can do these kind of things. We can do the payment stuff, but then we have a lot of AI developers that can do the AI part. But we need to spread the knowledge that this is also just such a perfect fit. So, and this is what we do here. So we'll see what comes out of that.
Yeah, and something that this is something else that you can do through WebLN. We didn't cover today, but maybe we're going to cover in a later workshop. I think, we'll definitely cover in a later workshop. Is you can use the WebLN, the key associated with the WebLN wallet, in order to do a login with Lightning, right? And so that's a really cool way if you want to have like a privacy preserving way to have a user have a continuous identity that you don't have to know anything about the user except that it's the same one that was there last time. Then you can use WebLN's login mechanism in order for them to just be a public key that they're logging in with. And that allows you to have like a persistent user session across different times that they interact with your application. Well, you don't have to know any personal information about them. And you know that they're always able to do payments, right? Because they logged in with a Lightning wallet. And so they're compatible with WebLN.
Yeah. Yeah, and you can, again, combine that, for example, with the L402 headers, where you then persist the token and the user can, when they come back, you just send the token again to the backend, and you can authenticate this request and see, this user already paid, they still have a budget, and they can still like download this image again or something like that.
Totally. Yeah. Cool. All right. I think, we're good to call it there. Boomy, this has been fantastic. Thanks so much. It was cool because for this, it was literally just like, hey, like select 2 random applications that look pretty cool. And then you can just add Lightning payments to them with like 10 lines of code. Right? Yeah,
it's really the fun thing is like it's you can make that short. It's 2 lines of code, right? Yeah. So, and the user interaction is so seamless that you get a prompt, you add a budget, and you not even get prompted anymore. So, and that's sending sats around is amazing, I think.
Awesome.
Yeah. Cool. One of the upcoming sessions that I also want to do is some of the tools, like Albi tools, some of the things that we just talked about, we wrapped into a JavaScript object again that, for example, I can have a Lightning address object, and I can request an invoice there, get the payment hash, get the payment request there, and then also verify the payment that it's settled just by comparing these hashes. What we're gonna do in an upcoming session. But if somebody wants to already play around with that, you can check this one out.
Yeah. And then last one, because I know we're running a little bit over, but we did start a little bit late, is do you want to show the Prism payments that you kind of set up for real fast? Because that's something for a lot of people have been kind of interested in terms of like, how do you split out payments across different agents and those kinds of things? So that's something that you've been doing good work for through Albi tools and that sort of thing.
Yeah, I mean, we also do a session on that. Okay. But for people who want to check it out, just a sneak peek, which is the Lightning.
The weather API.
Which is where I just used the weather API, but it's the same thing that you can for anything else. Code is down here. We're not going to look into that, but just as an idea here is this application running on Replit requests a payment from the user of 100 sats. With that 100 sats, the application is paying the API, like for example an AI agent, to perform a certain action. In this case, I'm just requesting a weather endpoint. I pay 20 sats here to the weather endpoint. And what this app is also doing, it's applying the value for value idea to the NPM dependencies. So any library developer that has Lightning information in the NPM package also gets a split of that. That then can even go further, like one NPM package can forward that again to multiple developers of this package. And obviously also the developer of the app gets the biggest share. So check it out, but actually I would like to do a special session on that one where we actually look at code again.
Yeah, totally.
Will be similar things. That's the great part. It's the same puzzle pieces. We request a payment from the user through WebLN. We use the LNUL spec to request invoices that we pay for the NPM packages. And we have the L402 spec to talk to the APIs. So, and actually here also the front-end application is talking to the back-end application through the L402 spec.
Yeah, amazing. All right. This has been great. Thanks so much, Boomy. I'll see you around.
Thank you. Awesome. So yeah, cool. See you around.
And broad.